This is a Semester 2 final exam review for Algebra 2, numbers 18 to 30. You probably can't see this graph real well in the copy I gave you, so here is the graph you should see on the page. We're going to use this graph in problems 18 and 19. In number 18, we want to start by determining the vertex and the equation of the axis of symmetry. Well, it turns out that finding the vertex and axis of symmetry for an absolute value function, which is what a V-shaped graph is, worked exactly the same as it did with quadratics. This here is the vertex, so the vertex must be at -2, 3. The axis of symmetry is the vertical line that goes through the vertex. All vertical lines have the equation x equals, and the x value that it goes through is -2. The axis of symmetry value for x always comes from the x value of the vertex. The second thing that we want to do with this is we want to determine the range. Oops, not number 20. Remember the range, the y values. The domain of absolute value graphs is always all real numbers. Every number can get plugged into the equation, but not every number can come out. Since this graph opens down, the range is going to be y is less than or equal to. And it's going to be less than or equal to its highest point. Well, its highest point is 3. All the rest of the graph is below that. Hence the reason the range is y is less than or equal to 3. In number 20, it says a financial advisor handles the transactions in a bank account. For every transaction, the advisor gets a 6% commission, regardless of whether the transaction is a deposit or a withdrawal. Write a formula using the absolute value function for the advisor's commission. Let D represent the value of one transaction. Well, first of all, let's figure out how you would determine commission. The commission would be 0.06 times whatever the person did, whether it be a deposit or withdrawal, and they said D is the transaction. So the commission that this advisor is going to get is going to be 0.06 times D. The thing is that D could be positive or negative, because it could be a deposit, in which case money is going in. It could be a withdrawal, in which case money is coming out. And we said that the financial advisor gets the commission irregardless of it being a deposit or withdrawal. Well, that can be taken care of very easily by using absolute value bars. So it doesn't matter if it's a withdrawal or a deposit, the number coming out of it is positive, and you'll multiply it by 0.06 to find the commission. Number 21. The force F of gravity on a plane varies directly with its distance d from Earth, and inversely with the square of its mass m. Write a model for this combined variation. Direct variation was the equation y equals k times x, while inverse variation was y equals k divided by x. And it turned out that we could do a combination of those, so more than one variation could be occurring in an equation. So to write the equation for this particular problem, it says the force F varies directly with the distance d from Earth. So that means I'm going to multiply d times some constant k that I don't know yet. And it varies inversely with the square of the mass. That means I'm going to divide k by m squared, because it said the square of the mass. This would be the equation that models the variation. Here's my direct variation, and here's my inverse variation with the square of the mass. Number 22. Are there any holes for f of x equals x plus 4 over x squared plus 3x minus 4? If so, name them. Remember, a hole was also known as a removable discontinuity. That means that I can cancel it with something from the numerator. All of our discontinuities are things that happen in the denominator of a rational function. Discontinuity. There we go. So, in order to determine if there's a hole, I need to first factor the denominator. The two numbers that multiply together to give you -4, but when you add them give you +3 are positive 4, and negative 1. So, since I can cancel those, that means x equals negative 4 is a whole or removable discontinuity. Remember that x equals negative 4 because a discontinuity is a value that makes the denominator 0. And you would need to add 4 to negative 4 in order to make it 0. In number 23, we want to find any vertical asymptotes of the function f of x equals x minus 1 all over x minus 3x plus 5. A vertical asymptote is a non-removable discontinuity. That means you cannot cancel it with something in the numerator. Well, neither of these factors can be canceled. So there are two vertical asymptotes. One of them is x equals positive 3, and the other one is x equals negative 5. In number 24, we want to find the domain of f of x. That means, what can I or can I not plug in for x? When dealing with a rational function, we know that the denominator cannot equal 0. So when finding the domain, I actually don't even care about the numerator. I only care about what values make the denominator 0. So if you set x squared minus 9 equal to 0 and solve, you're going to find out that x is 3. But you got to watch out because the other answer is negative 3. So it turns out the domain is that x cannot equal 3 or negative 3. Another way you could have done this is our special factor, and it factors into x plus 3x minus 3, which is why there are two answers to the problem, 3 and negative 3. Number 25 says, what do the y1 entries for x equal negative 1 and x equal positive 1 tell you about the rational function? Well, at negative 1, the y value says error, and at 1, it says error. Here's the thing. When you look at a table, you don't know if that error means it's a vertical asymptote or a whole. But it doesn't matter, because either way, it tells you that there is a discontinuity at that point. The graph doesn't exist there. So anytime you look at a table and the y value says error, that means that some sort of discontinuity is occurring there. And that discontinuity may be a whole, and it may be a vertical asymptote. Number 26, you want to mix a 10% lemonade drink with 100% pure lemon juice to make a 30% lemon juice drink. The function y is equal to 2 times 1.0 plus x times 0.1 divided by 2 plus x gives the concentration y of lemon juice in the drink after you add x gallons of the 10% drink to 2 gallons of pure juice. How much of the 10% drink must you add to get a drink that is 30% juice? So I want the concentration to be 30% or 0.3. So what I'm going to do is I'm going to solve this equation for x to find out how many gallons I need to add of this juice to get my 30% concentration. So I want you to notice some of the things I did, like I multiplied 2 times 1. I multiplied x times 0.1. This is just a proportion. So to solve the proportion, I'm going to cross multiply. I'm going to get 0.6 plus 0.3x is equal to 2 plus 0.1x. I'm going to subtract 0.1x from both sides, and I get 0.6 plus 0.2x is equal to 2. And then I'm going to subtract 0.6 from both sides, and I'm going to get 0.2x is equal to 1.4. And then I'm going to divide by 0.2, and I find out that x is equal to 7 gallons. So I need to add 7 gallons of the 10% drink in order to make a drink whose concentration is 30% juice. Number 27, it says, using the scatter plot below, if Ben had been able to keep up the pace he had on day 3, how many days would it take him to finish a book of 150 pages? All right, so we need to look at this graph to see what was going on day 3. Well, you may notice on day 3, he was reading 80 pages. So if he's going to keep that up, and he wants to find out how many days it's going to take him to read 150 pages, I'm going to use a proportion. So I'm going to do this. I'm going to do 80 pages, took 3 days, and that's going to equal 150 pages, and we want to know how many days that's going to take. So I'm going to get 80x is equal to 450, and 450 divided by 80 is approximately 5.625. So it's going to take about 6 days to read 150 pages. 28, we want to solve this rational equation. Now remember, what you can do is you can plug this into y1 equals, making sure you put that in parentheses, plug this into y2 equals, and find where the two sides intersect. The other option is to subtract 6, plug this into your calculator, and find the x-intercept. But you can also do it algebraically if you can figure out what the least common denominator is. Well, if you look at the denominators, they are x plus 3, and 1. The least common denominator is x plus 3. So the first fraction needs an x plus 3. The second fraction needs an x, and the third one needs both. When we find what we need to multiply each numerator by to get a common denominator, the denominators become negligible. That means we no longer care about them, which is why I just didn't write it. Well, this is just a general run-of-the-mill algebra problem. It's long, but it's run-of-the-mill. 12x plus 36 plus 6x squared minus 6x is equal to 6x squared plus 18x. Well, the nice thing about this is when I go to solve, the 6x squareds are going to cancel. The left-hand side simplifies to 6x plus 36. I need to subtract 6x. I get 36 is equal to 12x, and x is going to equal 3. Don't forget to ask yourself, is the answer extraneous? That means if you plug it back into the original problem, does it make any of the denominators 0? Well, it doesn't, so it must be the answer. In number 29, I'm going to simplify 5 over x plus 2 minus x minus 1 over x squared plus 5x plus 6. In order to add or subtract a rational expression, you must have common denominators. Now, there are a couple things I'm going to do. Number one is I'm going to change this numerator and make this an addition problem instead of subtraction. The second thing I'm going to do is I'm going to factor the denominator here. Okay, so here are my two denominators. I have x plus 2 and I have x plus 2, x plus 3. The least common denominator is x plus 2, x plus 3. So now the first fraction needs an x plus 3. The second fraction doesn't need anything because it already has an x plus 2, x plus 3. Now that I have a common denominator, now I can distribute and combine like terms in my numerators. I get 5x plus 15 minus x plus 1 when I combine like terms, I get 4x plus 16 and the numerator has a common factor. It's 4, and when I factor out of 4, I'm left with x plus 4. But you'll notice it doesn't result in me canceling anything else out. So this is the answer, no matter what. Remember, this is not an equation. We're not solving it. We're only simplifying. Number 30 is not a problem we dealt with. It's normally a problem that I do with the honors class. Bill can mow the yard in 4 hours. Ben can mow the yard in 3.5 hours. To the nearest tenth, how long will it take them working together to mow the yard? Well, I want them working together to mow one complete yard. And it doesn't take a lot to realize that if they're working together mowing one lawn, it's going to be less than 3.5 hours. So remember, this is a multiple choice test. So if any of the answers are bigger than 3.5, you can cross them off right away. The way this problem works is because Bill mows the yard in 4 hours, we're going to take my time together and divide that by 4, plus the time together and divide that by Ben's time. This becomes a rational equation. Now, how do you solve the rational equation? Well, you can graph it and find the point of intersection. You can subtract 1, set it equal to 0, and find the y-intercept, or you can do it algebraically. If you do it algebraically, the common denominator is going to be 4 times 3.5, which happens to be 14. So in order to get a common denominator of 14, I'm going to multiply the first fraction by 3.5. I'll multiply the second fraction by 4. And then the third fraction needs a 14. I'm just going to solve that equation. That equation is going to be 7.5t is equal to 14. And 14 divided by 7.5, is going to be about 1.87 hours. So together, if they mow the lawn, they can do it in just under 2 hours.